Welcome to the module on running casing and cementing. Today, we will learn about factors that increase the risk while running casing and liner, mitigate actions for losses, correct actions for swab and surge, precautions while running casing, maintenance of fluid column, shut-in procedures when running casing, cementing casing and liner, right weight and quantity of cement, and bottom hole pressure, BHP, during cementing. Casing is a series of steel pipes that are run into a drilled oil well to stabilize the well, keep contaminants and water out of the oil stream, and prevent oil from leaching into the groundwater. Casing is installed in layers, in sections of decreasing diameter that are joined together to form casing strings. To prepare and pump cement into place in a wellbore, cementing operations may be undertaken to seal the annulus after a casing string has been run, to seal a lost circulation zone, to set a plug in an existing well from which to push off with directional tools, or to plug a well so that it may be abandoned. Before cementing operations commence, engineers determine the volume of cement to be placed in the wellbore and the physical properties of both the slurry and the set cement needed, including density and viscosity. A cementing crew uses special mixers and pumps to displace drilling fluids and place cement in the wellbore. Factors that increase the risk while running casing and liner. As casing is large outside diameter tubular, has the high chance to cause swab and surge due to smaller clearance. Using centralizers will improve the job, but at the same time will increase the chance of surging. Following factors will increase the possibility to cause swab or surge. High gel strength, or viscosity, high running speed, more than 6 meters per minute as per recommendation, and closed end or ball bit. Running casing with free rotating guide shoe will prevent casing stuck. Mitigate actions for losses. While running the casing in hole or pull out of the hole, POOH, monitor trip tank for minor, major or total losses. Confirm mud density is same throughout. Good hole cleaning. Control speed of running hole to avoid any ruptures. Use of centralizers and self-fill float will reduce surge pressures. Factors that affect surge and swabbing. Surge is controllable by reducing running speed, circulate to break the gel strength and reduce viscosity. The increase in surge or swab pressure is also attributed to different flow phenomena including pipe eccentricity, geometric irregularities, acceleration, and dynamic effects. The present study analyzes the bottom hole pressure variation resulting from the reciprocation of the drill string with the narrow slot model. Balled up bit/BHA acts like an excellent piston, and this will cause greater swabbing effect. If the well is at near balance condition, the well will have more chance to be under balance due to swabbing. Correct actions for swab and surge. Swabbing. To reduce pressure in a wellbore by moving pipe, wireline tools or rubber cupped seals up the wellbore. If the pressure is reduced sufficiently, reservoir fluids may flow into the wellbore and towards the surface. Swabbing is generally considered harmful in drilling operations because it can lead to kicks and wellbore stability problems. Surge. Surging is when the bottom hole pressure is increased due to the effects of running the drill string too fast in the hole. Downhole mud losses may occur if care is not taken and fracture pressure is exceeded while running in hole. Things to do for avoiding swab and surge. Pump out while pulling out of hole. Reduce pulling speed. Keep the hole fill while tripping out. Monitor trip tank closely. Circulate to condition mud. If total loss occur, stopping tripping, start FOV, start top filling the well with base fluid. If minor losses, reduce running speed and monitor the return volume. Precautions while running casing. Change the rams to the casing size, on surface stack, and test the BOP bonnets. Prepare a circulating head. Ensure a crossover from casing to drill pipe available to allow the string to be hung off if needed. Take care while filling up the casing. Use clean mud and ensure that junk does not fall into the casing. Record the annular volume between the casing and open hole and outer casing. Calculate the running speed to allow an acceptable fluid velocity and a limited surge into the open hole. A record of the tank level is necessary and should be compared while the calculated volume increment due to the metal displacement of the fluid. Maintenance of fluid column. When running casing, primary well control will be maintained by keeping sufficient fluid height in both the casing and the annulus. The casing should be filled every joint as time allows. Use clean mud and ensure that junk does not fall into the casing. Shut-in procedures when running casing. Shutting in a well while running casing is similar to shutting in a well when tripping drill pipe. The tripping must be stopped, flow check the well, if possible, shut in the well by 1. Installing the full opening safety valve, FOSV, with crossover sub, then close it. 2. Close the annular or the casing ram to avoid any pressure from annulus. 3. Open HCR for choke line then record pressure. If hard, shut in. 4. For soft shut in, open HCR then shut in the well. Then close remote choke before calling the supervisor. Then record shut-in pressures. Cementing casing and liner. After casing setting, condition mud is circulated and then rig up cement and prepare for cement job. Kicks may have been experienced both while and after placing cement. So all operations must be monitored and recorded for mud gain or losses. The cement design must ensure an overbalance at the bottom of the hole in both static and dynamic conditions throughout the cement job. Right weight and quantity of cement. Lightweight cement. Cementing casing across highly depleted zones and weaker formations requires low-density cement systems capable of reducing the hydrostatic pressure of the fluid column during cement placement. Heavyweight cement. High-pressure zones may require heavyweight cements such that the density of cement in the annular column is greater than the fluid pressure in the permeable formation. At the same time, hydrostatic pressure should not exceed the fracture gradient so as to avoid fracturing the formation during cement placement. Bottom hole pressure, BHP. During cementing, BHP is the total pressure exerted on the bottom of the well. It will increase once cement start to be displaced into the annulus. BHP also will be affected with annular friction losses as the cement slurry is more viscous than the displacement mud. BHP will decrease once cement start to reach to the thickening time. Losses will reduce the BHP and may cause a kick, case well geometry events that could result in formation fluid entering the casing and casing annulus. After casing in place and cemented, well integrity should be checked. So, logging jobs are performed. Sometimes, formation fluids enter between casing and casing annulus that affects well integrity. So, it may cause collapse, burst, and fracture formation in the casing. So, casing grade and logging jobs must confirm that cement is not leaking. Let us now go through an example to understand more about the concepts we have learned. Thank you for learning with us.